last example of recursion is the Hanoi problem. And basically, visually speaking, there's a nice website, and you have a link to this website in Blackboard. And the idea is to take these disks and move them over to this third peg here, but doing one disk at a time, and you can never move a big one on top of a small one. In other words, if I were to move this, I can move this top disk here, but I cannot move this on the top, because then you don't get to see the bottom one. If you're looking on top of these things, that big disk would cover the small one. You can't do that. So let me restart. And how do we do this? Well, let me show you the code for that. Let me show you the code for this. The code is very, very simple. It's a very, very simple piece of code. And we start off the process. I really should have went down here and started off the process by saying Hanoi, move 4 disks from the first peg to the third peg using the second peg as temporary storage. Okay, let's understand what this means. Move 4 disks from the first peg to the third peg, the destination. This is the source destination, and the peg number 2 is the temporary. Okay, let's bring this back here. Move 4 disks from the first peg to the third peg using a scratch pad temporary peg here. Okay, how do we do this? Let's take a look. Let's take a look right here. See, source, destination, temp. The number of disks are 4. Okay, first step. Base case is if count is 0. If count is 0, then you have nothing to move. And if there's nothing to move, that's great. There's nothing to do. But count starts off at 4. And if 4 is bigger than 0, we're going to do some coding. Now, take a look at how small this code is. This is a kind of a complicated task, but if you think recursively, it's an easy task to perform. This guy here says, all right, in order to move 4 disks from source to destination, what I need to do is move the top 3. 4 minus 1 is 3 disks from source to temp. So the idea being, I don't care how, and by the way, I don't care how you do it, as long as you do it. Okay, let's go ahead and let's go solve slowly. Okay, and then what I'm going to do is I hope I have a way to stop it. Okay, I'm going to move. This first line here says move 3 disks from source to temp using destination as a scratch pad. And you got to believe that what's going to happen is after you execute that line, these 3 disks will make it over here. Let me see if I can start. Okay, stop right there. That's what that line basically said. I moved 3 disks from the source to the temporary using the destination as a scratch pad. Okay, now you're free to take this big disk and move it over to the ultimate destination. Move disk, I guess that would be move disk 4 from source to destination. Okay, and that's it. Stop right there. That's what that 276 just did. And now what we're left to do is to take these disks, move them over to the destination. Now remember, this is the temporary peg at this level, so I want to move 3 disks from the temporary peg to the final peg, the destination peg, using the source peg as the scratch pad. Okay, this is what I'm doing. Move 3 disks that you know are in the temporary, move them to destination, using source as the ultimate, as the scratch pad. Now, don't worry about all the sub-micro operations. At this level, you've got to believe that this piece of code here is going to move 3 disks from here to the destination using the source peg as scratch pad. Okay, because at this point the source is that's the empty peg. Okay, and if I continue this, see all those sub-micro operations, that's all done using the various levels of the Hanoi. Okay, this problem here would be almost impossible. No, I wouldn't say impossible. It would require pages of code to write properly all the operations you need to perform here. Now, I have different versions of this. Okay, the problem with this void method is that, okay, you got the basic engine here, but if I wanted to know what the third move was, you don't know what the third move is going to be. So I have a variety of ways of doing this. I guess the best way is to use this array list. And I'm only going to talk about the array list version. Okay, but the logic is pretty much the same. As long as you've got something to move, you're going to execute this code. If there's nothing to move, remember there's a return value that stops this. If there was something to move, you're going to return something. But when your execution comes here, there's nothing to move. If there's nothing to move, then I return an array list of no moves, empty, no moves at all. So if you've got 0 things, there's no moves to perform. Okay, let's come over here. If there's something that you want to move, go ahead and create an array list of strings. That string would represent what the actual move. This guy here, Hanoi 3, which is the third version here, will return all the moves, all the text, the text that's moved disk 1 from source to destination. That's going to be the description of the actual move. Move 3 disks from source to temp using destination, same basic engine, but what this returns is an array list of all the moves necessary to move 3 disks from source temp to destination. Okay, using the source to temp, using the destination as the scratch pad. So this returns an array list. What I'm going to do next is make the move, add that string to the array list, okay, and then what you're going to do is, let me put a little space there to be consistent, move those 3 disks from the temporary to the destination using the source as the scratch pad. This is going to return an array list of all the moves necessary to perform that task. And so what I'm going to do is take those moves and add every move that gets returned in this array list to this return value. Okay, and so I add up all those moves together and return that array list, and there you go. Now you've got a nice way of returning an array list of all the moves necessary. And let's take a look at that. I think I have one here. Let's do Hanoi 3. Well, first let's do Hanoi 1 just to prove that it works. Up. That's because I got to get rid of that triple X and come over here. And I think I got 2 main methods here. Yeah, let's do triple X on this guy here. And now it should work. Okay, classic Hanoi, move disk 1 from 1 to 2. You can follow that along. That's the engine. There should be 15 moves here. Now let's go ahead and do let's comment out this version 1. Version 2 is strictly strings, array of strings. Version 3, Hanoi, that returns an array of moves. Okay, let's go here, 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 here. Oh, I'll show, this is cool. This is way cool. What I'm going to show you next. I'm going to kill 2 birds with 1 stone. Alright. Then those 2 types of iterations. Let me just quickly, yeah, it's working. Then those 2 types of iterations. So remember, Hanoi 3 returns an array list of moves, and each move is a string. This is something that you got to get used to in data structures. You're going to see this a lot, where you want to iterate through every move that's in your collection. An array list is a collection. You're going to see this a lot. An array list is a collection. So basically this is, okay, I have this object that iterates through and visits every element of your collection. And what this is typically the pattern that you're going to have. Is there something in your iterator? Is there something to visit? Has next? Is there something to look at? If you turn true, grab it. Grab that move. Store it, print it out. Keep doing this until this returns false. If this returns false, then don't execute that. There's false. There isn't anything next. The iterator has exhausted all the elements inside your collection, has visited every one, so you're going to exit out. This is an iterator. This is the pattern that you're going to be seeing a lot when we do linked lists and trees and what have you. So get used to this. Now, buried inside the enhanced for loop, you may have seen this before with arrays, but this works with collections as well. Hanoi is an array list of strings. So for every string that's inside Hanoi, and it's guaranteed that you're going to visit with that enhanced for loop, you're going to visit every string inside that collection in order. The 0th one gets visited first, the first one gets visited next. What's going to happen is that iterator does the same thing. It's guaranteed to maintain the order that's within the array list, the order in which you put those strings in there. This and this are exactly the same. Basically, an enhanced for loop is a piece of code that creates an iterator and does this automatically. And it saves you from having to create an iterator. That's what the enhanced for loop does. So for every string, you got the string printed out and you're good to go. So understand that an iterator, if you have an iterator, you have a little bit more control over what you want to do with that iterator, because you have a method that says has next and next. Now this guy you have really no control. The internal iterator here basically does this automatically, so there's no way to stop it. There's no way to go backwards or forwards, not like with a regular iterator. So this is something that you should know and be familiar with. And I just ran it and it worked great. All right, so we'll stop here. These are all the examples I can give that I can give you. We can go into many more examples, but there's it's time limited. But this gives you a good background as to what you need to do to execute to think recursively. All right, we'll see you in the next video.